Last December I got myself an espresso machine and I absolutely love it. For it, my friends gave me a tamper that they couldn't use because they have like a smaller 57mm machine and mine is a standard 58. But if you're at all familiar with like high-end cycling parts, Tune is a brand that is making like super lightweight carbon fiber stuff. And this tamper too, they're selling for I think like 140 euros. This is way nicer of a tamper than I'm ever gonna need, but like there's no point of not using it. But I thought the least I can do is to make them a nice tamper that would perfectly fit their machine. And while I was at it, you know, why not also try out the 4-axis machining feature on my Snapmaker? Obviously, I'm shooting this intro after I've already finished the project, and I think this turned out pretty nicely as well. This is some nice hardwood that I still had around, and not only was this something that I'm proud of that I made, because this, honestly, this looks really good, but it also taught me a lot about 4-axis machining, about the cam involved, and just about solving problems in general. So follow along for this fascinating process right after a message from today's sponsor. Private internet access. I like looking out my window. It's a nice view, there's birds out there, the occasional hedgehog, but I don't think I'd want this to be the only window I could ever look out of. There's just so much more to see. What traveling in a tinted out sedan can do for your body and mind, a VPN can do for your experience online. That's one of the reasons I'm using Private Internet Access VPN. Private Internet Access hides your IP address and encrypts your internet connection. This way it shields your digital life from the eyes of your internet service provider, network admins, and government censors. PIA now has servers in 84 countries and every single US state, so you can experience the internet as if you were practically anywhere in the world. The client is open source, but you can use any of your own OpenVPN or WireGuard compatible clients as well. And PIA does, of course, work with all of your favorite streaming services. If you sign up for the 2-year plan, you'll get a deal at 83% off, so it comes out to just over $2 a month, and you'll also get an extra 4 months for free at this link. If you need it, they have 24/7 live chat support, and you can try them risk-free with their 30-day money-back guarantee. Thanks again to Private Internet Access for sponsoring this video. First order of business, converting the Snapmaker from 3D printing to CNC. However, the laser module that I still have goes right back into the box. I'm still not comfortable using that thing. What I can say is that, you know, even though this stuff is super tiny, it does feel quite nice and robust. Like there's very little backlash in the whole mechanism, and it all feels like it's adequate for what we're trying to do here. That's the thing about the Snapmakers. They're okay 3D printers, they're okay CNC engravers, they're okay laser engravers, but going from one mode to the other takes so much work. It's just so many little tiny screws to do and undo. It's like 10 minutes just to start a print if you were doing CNC before. So this life center feels like it's very wobbly and doesn't do a lot for centering, but it might be okay. As soon as you put some tension on it, it loses a bit of its slack. We'll see how well this works. That's really going to be interesting because even the included sample block, I think this is, I forget the name, but this is like an expanded sort of foamy sort of plastic sort of material. This barely fits. Like this is at the widest, longest setting, and yeah, I can't even get this in here without taking off the tailstock. But yeah, that's what we have to work with. And next up, we've got to make some CAD files to mill with this. I realized pretty quickly that the software Snapmaker gives you, called Luban, really isn't gonna cut it here. It does some very basic, It does some very basic 4th axis processing, And it might be okay to do like an image engraving on a cylinder or something, but once you try to do a real 3D part, there's just not enough control. You don't get multiple strategies. There's no rest machining. It's just super basic. So this isn't gonna do it. This would be like 30 hours of machine time, best case. So really the only reasonable thing to do was to set up the machine in Fusion 360, and this took me a while to figure out. Thankfully there are some post-processing files available. This looks like it's gonna work. I can do full simultaneous 4-axis, I guess 3-axis technically, machining. I can do planar machining from each side. Let's give this a try and see if we can make a quick sample part just to verify that the G-code works, the machine works, and we can then move on to the proper material. I'm using these single flute coated solid carbide end mills in 3.175 millimeters diameter. What a weird size, but I've used them before. They're super sharp and they cut super nicely. Though, good thing I did this test cut up in the air, because if I had done this at the actual height, I would have cut straight to the tailstock. All it means is that I zeroed out the work center on the machine to a different position than I had set in cam. So, quick re-zeroing and we're ready for the first cut. Okay, quick intermission here. This cut turned out super nicely, like it feels super smooth and crisp, even though this is like cheap softwood. With the single flute cutter, this machine did a really impressive job, especially considering that this entire setup is pretty wobbly. But the fact that the entire control panel is using an unsecured USB-C connection, and as soon as you slightly wiggle on this, the cable comes loose. That's a bit of a bummer. This is the brains of the machine. You saw me use the panel and do all the controls. This is basically an Android 7 phone. But also it reads all the data off of the USB drive and then it streams it to the machine's firmware. So if this comes loose, if this has like a bit of a connection hiccup, the entire machine stalls. And you saw that message, the reconnect did nothing, and now I'm gonna have to re-find my work zero. I hope I can reuse this piece of stock. It's just a bit of a pain. I don't understand why they're not using the same type of locking connector that they're using literally everywhere else on the machine for the one thing where it's really crucial. I don't know. I'm gonna add a couple zip ties to this, hope that it's gonna, fit in there well enough, and then we're just gonna retry the entire thing. I did the roughing pass with just a 2.5D adaptive, and then the spiral circular continuous pass as sort of a finish pass. I did have a third one planned with a ball end mill, but I'm gonna skip that. I think changing the tool with no tool length sensor, not optimal, not easy enough. And I think for the final piece, I can make it work with just the single flute straight end mill with a bit of a trick. And yeah, the surface finish on this part, especially considering how wobbly this setup is, looks really good. I think somewhere along the way we lost a millimeter on the y-axis, so you can see one of the cuts was a bit deeper and it was cutting more on one side than the other, but for now it's fine. However, what's not fine is the fact that we are so limited in which portion of the work we can work on. So this is the maximum extent that we can get to. And I did measure like the distance between where we can do our first real cut and where the tailstock starts is like 4.5 centimeters. And considering that this is the part we're trying to make, this handle right here needs to be roughly that size to fit well. That is simply not going to be enough. Now you can adjust the position of the tailstock. I already took the screws out after this cutting job. You can adjust the position of the tailstock and of the B-axis, of the rotary axis, but this is already at its maximum extent. You can only make these closer. I tried a couple things. I was trying to see whether I could clamp this tailstock adjusting mechanism on this area here so that this would move back in the clamp. That didn't work. I could not get this disassembled. The other thing I thought was I could remake this plate and just use some aluminum stock I had and just make a longer version of that. In fact, the rotor axis for the A350 has a longer bed on it. So that could totally work as well. Because really there is no reason that this entire motor and the chuck need to be within the working envelope of the router. Like, you're not going to be cutting, hopefully, you're never going to be cutting the rotary axis mechanism itself. But then I tried something that would maybe be considered unconventional, but that's how I like to roll. And that's the fact that we can, instead of using all 4 holes, we can just use 2. And we can basically let it hang off the back here. And I tried this, I screwed it down, and really with it hanging off the back like that, it's not any noticeably less rigid than with it bolted down with 4 screws. So I think this is just the way I'm gonna try this. It gives us enough space to work with, and this sticking out the back, not a problem at all. Let's go and prepare some proper wood and size this part to the actual tamper that we're trying to make. I'm trying to rough out these blanks as close as reasonably possible to round before I put them into the machine. Not only does this allow me to chuck them up in the 3-jaw at all, but it also saves a ton of machining time because now we're already much closer to our final part shape. Okay, let's talk about cam. I'm doing all this in Fusion 360, which of course has a huge amount of cam tools built in. The first operation here is some clearancing around the chuck. Basically, we're machining waste material, but we do need this clearance for later operations. I'm using the same 3D adapter strategy here that you would use on a 3-axis machine, but I'm using 4 of them, and I'm rotating the stock 90 degrees between each pass with rest machining. Then I'm doing the exact same thing again, but around the actual part this time. 4 more passes of 3D adaptive, but this time with some stock to leave so we can have some material to remove in the actual finish passes. And you can see there is some bit misalignment happening here, which is almost impossible to avoid on this machine. This means there are ridges between the individual passes where one side cuts a bit deeper than the other. But that's what finish passes are for. I'm actually doing 2 finish passes here. A first one with a bit of stock to leave, just to equalize the amount of material that the finish pass, the actual finish pass, is going to remove. With a more even amount of material to remove, the cutting pressure is more even, which means we get a more even surface finish in the end. For this, I'm using Fusion's rotary toolpath with the spiral generation option. I've also got the tool offset to the side a bit, so we're more cutting with the sides of the tool and not with the end, which typically makes for a better surface finish. But I did learn that I should have used line here, which with the specific end mills that I'm using, makes for a much cleaner surface that almost needs no sanding. As is, I ended up with a couple fuzzies, but those were easy enough to sand away by hand. I still needed to turn down the tamper base to the correct 57.1mm to fit my body's espresso machine. So I grabbed some scrap, made a quick mandrel, and lathed down the functional surfaces of the base. This stainless actually cut beautifully. And with these printed adapters, it was super easy to chuck up our finished part in the lathe as well, where I then parted off the base and drilled and tapped for M10 to attach the actual stainless steel tamper base. a couple of coats of food-safe hard oil, and here it is. You can kind of see the seam between the two boards. I know that could have been nicer, and I could also have done a lot more design-wise. I could have hollowed out the inside or done some scales or anything really. This is a full 3D workflow, but most of all, this thing needs to fit well in the hand, and it does that, and it does so while looking honestly very nice, I think. But of course, we've also got to talk about the rotary setup on the Snapmaker. And yes, it did ultimately work. It did produce a part. It's not very good on tolerances. And if you look at the setup, like you can tell this is not meant to be a 4-axis machine. But I've got to give credit where credit is due. This rotary axis itself is actually very nice. This has a harmonic drive knockoff, I guess, in it. There's almost no backlash. This thing is solid. And it did work with no additional ill effects extended all the way to the back. This tailstock, however, is worse than I thought it was. There's also no real way to align the bit with the axes. So you can kind of use the tip of the tailstock, which revolves around by a millimeter. And then for the x-axis, left to right, you're supposed to use the stock itself, but that's in a 3-jaw. And a 3-jaw by definition doesn't chuck up your stock perfectly on center. So that's going to be off by half a millimeter. And then worst of all, I guess, there's no way to align the rotary axis with the y-axis movement, so that might be like on a taper as well. This setup is not going to give you mechanically accurate parts, and if you try, like, you're going to have a hell of a time. But for parts that just need to look okay, this can work. Nothing about this is solid. In fact, you could see the bed wobbling back and forth by a huge amount every time the cutter plunged in, but like I said, you can kind of work around it, but like if I were to choose a 4-axis milling setup, this probably wouldn't be it. All right, let's get this over to my buddies and see if it actually fits in their machine. Yeah, I couldn't resist and I made another one with a little extra 4-axisivity. This is the second attempt. I broke the first one, but I think overall it turned out really nicely with all the stuff I learned along the way. But that's it for this one. Thanks for watching, keep on making, and I'll see you in the next one.